Okay, 5.3 optics test, question 12. Okay, so I'm going to go through question 12, which is a 5-mark question with you. So, a student investigated how a converging lens can be used to produce a magnified image onto a whiteboard. So, obviously, if I had the paper in front of me, I might just underline this, but it's a converging lens. We're getting a magnified image, and it's using a whiteboard. This question is quite difficult to visualize, so this is very important. In a darkened room, the student placed a smartphone, so we've also got a smartphone involved, 9 centimeters away from the converging lens. Okay, so converging lens, smartphone. The phone's display was projected onto the whiteboard. The converging lens was 75 centimeters from the whiteboard when a clear image was produced. Right, so this is where it's quite tricky to get this. So, what in terms of the setup of this question, to begin with, let's just start. We've got the whiteboard. Okay, and this is where the image is being produced. And it says they're placing the lens 75 centimeters from the whiteboard. So I'm going to put the lens here. And that is a distance of 75 centimeters. I'm going to just start changing everything into meters. So 0.75 meters. And we're told that the student placed a smartphone 9 centimeters from the converging lens. So smartphone 9 centimeters. It's not to scale this diagram, but I'm trying to keep it sort of semi-realistic. That's your smartphone. And the display on the phone contained 2 dots that were 5 millimeters apart. So we've got 2 dots on the smartphone that are 5 millimeters, and 5 millimeters is 0.005 meters. And the student stood 4.5 meters from the whiteboard and viewed the image of the dots. So we've got the whiteboard, so we've got 4.5, so it's as far over as I can go. Here is our student, so I'm just going to draw them as a line. That's our student, and that distance there is 4.5 meters. Now, although I did that in a few steps, it took me a long time to figure that out, okay? It's not the easiest things. I had to read it over and over again, make notes, make sketches, redo those sketches. So don't think you can just produce that sort of instantly. That took a bit of thinking, okay? Once you've got to this part, you've done, I think, the hardest bit of the question. Getting this is the difficult bit. So rays of light from the images of the 2 dots on the whiteboard are incident at the student's eye. So let's put the student's eye, let's just make the student's eye here. Okay, so this is our student's eye. With an angle of theta between them as shown. So we are seeing those 2 dots on the screen. And remember, we're told that it's a magnified image, so even though they're 0.005, I'm not sure how far apart they're going to be here, but I know they're going to be further apart than they are here. So let's make them slightly further apart. Okay, I do not know at the moment what this distance is. Now, we're told, let's just make sure the eye is in the middle, so I'm going to make that go into here. So from there, we're told that this angle there is theta. Okay, and the student could distinguish the 2 dots if the angle theta was greater than 0.0003 radians. Okay, so theta has to be greater than 0.0003 radians for clarity. and deduce whether the student could distinguish the two dots clearly. So essentially what we've got to do is work out this angle. If this angle is bigger than this, then we can say that the student can view these two dots clearly. But obviously we can't just calculate this straight away, we've got to do some calculations to begin with. So let's just start by putting some information. 0.75 meters, the distance from the lens to the image. Okay, so this is the image. We give that the letter V. The smartphone, that's the object in this example. So the distance from the lens to the smartphone is U. So we have V and we have U. Now what we can do is work out, what we want to sort of get to is to work out this distance here between these two dots on the whiteboard screen. Because if we have this distance and we know this distance, then you should be able to think, well, trigonometry is going to allow me to work out this angle. So our objective is to get this distance between these two dots on the whiteboard screen first. Now I know that the magnification links together the image height and the object height. So my first use to calculate, I want to calculate the magnification so I can then calculate the image height. I can also calculate the magnification using V and U. The image distance divided by the object distance. So the magnification V, which is 0.75 meters, divided by U, which is 0.09 meters, is equal to 8.3. No units because it's meters divided by meters. Now I can use the knowledge that the magnification, or that I'm going to use the formula, that the magnification is equal to the image height divided by the object height and I know that the object height is 0.005. I know the magnification is 8.3 because I just worked it out, so you can see I've only got one unknown in this formula. So the image height, which on the diagram is this distance between the two dots on the whiteboard screen, is going to be equal to 8.3 times 0.005, and that's 0.042, and this is in meters. So I've now worked out, sorry, it's off the screen, I've now worked out the image height here is 0.042. Now I'm going to just slide this over, so I should maybe done it the other way, so you can still sort of see the diagram here, because this is important. So we've now put, so we can add this 0.042 to the diagram. So what we have at the moment is a triangle with, if I draw it again, with this distance here being 0.042, we don't know these lengths, but we do know that the distance from, remember this is the eye here, to here is 4.5 meters, because that's how far away the student is from the whiteboard screen. Okay, so 4.5 meters. This is 4.5 meters. Okay, and this angle here is theta. So this angle from this line to this line is theta. Now what we're going to do is take half of that triangle and we're going to use it to work out what theta is, and specifically actually theta over 2. So I'm going to take, let's just take this triangle here. So trying to be consistent. So that's 4.5 meters. from here to here. This is now theta over 2, okay, because it's half of this angle. And this length here, which was 0.042 here, is 0.042 divided by 2 meters. And that's a right angle. So, 1 second. Sorry, someone at the door. Right, let's continue. Where were we? Yeah, so we're going to use trigonometry now. So, you know the basic formula, tan, we use tan, it's tan theta, tan is equal to opposite over the adjacent. So in this case, the angle is theta over 2, and it's equal to the opposite, which in this case is this, divided by the adjacent, which is 4.5 meters. And if you solve for this, you will end up with theta. You will calculate that theta is equal to 0.5 of a degree, so it's quite small here. Okay. Now what we've got to do from here is work out whether the angle, so we've got to work out if theta is bigger than 0.003 radians for clarity. Okay, so we've got one angle in degrees, one angle in radians. It's just an extra level of just being complicated. So is 0.5 degrees bigger than 0.003 radians? If so, we have clarity. We have a clear, we can view these dots clearly on the whiteboard. So you might want to basically go from, well, I think 360 degrees is 2 pi radians. So that means 1 degree is, well, I've divided that by 360. So I divide that by 360. So that's 2 pi divided by 360 radians is what 1 degree is, but I've got 0.5 degrees. So times in by 0.5 will give me 0.5 degrees, and it's equal to, well, 2 pi divided by 360 times 0.5 radians, because I've times by 0.5, and that means I have 0.5 degrees is equal to pi over 360 radians, and if you put that in your calculator you will get an answer of 0.0092 radians. So 0.5 degrees is 0.0092. Now 0.0092 radians is greater than 0.003 radians. So what do we have? We have clarity. Okay, so clarity. And that means student can distinguish dots. Okay, so not the easiest of questions by any means. Hopefully that helped in going through this, and that will be worth 5 marks.